It's time to start. I want to introduce our next speaker. He came from the Netherlands. Mark is a passionate software developer. In Q42, the company he works for, he takes care of global infrastructure to make Philips Hue Cloud up and running. Mark will tell us about Google Cloud and how it powers Philips Hue. But before we start, let me share some interesting facts about Mark. Mark told us that he likes snowboarding a lot. Also, he likes to drink different sorts of coffee, mix it, especially coffee from different regions, and add some cube sugar, a lot of sugar. And he's a board game geek and even tried to kickstart his own game, Dreamcatcher. Please join me in welcoming Mark von Straten on stage.
Awesome, thanks. So, welcome everyone at one of the last talks of this awesome conference. I hope you have all had an awesome time and enjoyed yourself. Today, we are going to talk about how the Google Cloud powers your Philips Hue Lightbulbs. As my host already said, my name is Mark van Straten, and I work at Q42 in the Netherlands. We are a technology agency which takes on all different kinds of projects, from very small, like 2-week prototypes, all the way up to year-long partnerships. As long as our solution is internet connected, we have the capabilities to create them. Or as I'm used to say, like, we are a big bunch of nerds who like to make impact, things that make people smile, things like Philips Hue. Let's do a very short show of hands. Who knows what Philips Hue is? Cool, so we have quite a few people who already know the product. Let us do a short recap. Philips Lighting is world-renowned for one of their original inventions, the light bulb. But they have already been searching for a way to transform this product into something more. They wanted it to be more than merely illumination. They wanted you to be able to interact with your lights, have them be a source of information. So Philips formed a partnership with my company Q42, in which both parties could do what they do best. They created the lights, and we built the connectivity to the cloud. My role in this partnership is that I'm one of the architects responsible for the infrastructure, making sure that your lights are always reachable and will respond as fast as possible. When I was preparing my talk for today, I realized that a run-through of our cloud infrastructure might be a bit boring. And also, given that this talk is one of the last talks that you will attend to today, I changed it a bit. So instead, let me tell you a story. This is the road trip that we have undertaken since the inception of Philips Hue up until this day, and I can share with you a few of the big challenges that we have overcome. So let's get back to when we were starting. Philips Hue was originally launched in October 2012. We started working together with Philips while the hardware prototypes were still being iterated upon. This, for instance, is a near final prototype of the initial Hue bridge for your home, which we still have at our office. We believed in the vision that Philips Lighting had about the enormous potential that Philips Hue contained to become a big success. But that did not mean that the market would catch on. We had no idea how fast consumers would start buying this product. So what we needed to do was build a minimum viable product and get it onto the market as fast as possible, with as little investment as possible. Luckily for us, hosted cloud solutions were just barely becoming mainstream. We were just a small team at that moment in time of 2 engineers who did not want to have to deal with production issues on Sunday evenings. So AppEngine seemed like a very good fit. It provided us with the scaling opportunities we needed if the Philips Hue product became an overall success, without us having to worry about physical machines in racks in a data center. Google was also very happy to have us, because they were in search of a partner to showcase their hosted cloud proposition. Q42 with Philips and Google, that was a dream team coming true. But before we could have a physical product be shipped to the consumers, we needed to solve the biggest issue of physical hardware, handling firmware updates to those devices. Philips already had a service for this, which they had been using for televisions and for medical equipment. And nowadays that product is called the Health Suite Device Cloud. As an added bonus, it maintains a low data socket connection to the devices, so we could ping them and program an action, like, for instance, doing HTTP requests to our AppEngine backends for outstanding commands. This results in devices which are idle not making HTTP requests, which cost money, to our backend at the cost of adding a few additional seconds of latency. So our initial cloud solution looked like this. You could send a command to our AppEngine backend, which would queue it, and AppEngine then send a notification to the HealthSuite device cloud to wake up your home system, so it could start doing HTTP requests and pick up your commands, and presto, there was light. The fact that this round trip took like somewhere between 3 and 25 seconds was acceptable at that time, since we were still building the minimal viable product on which we could start iterating. And also, most people did not use the remote connection while they were at home, so they could not even observe this latency. But we also had to think about impending doom. What if this persistent connection was disrupted? We would then not be able to notify the system in your home. But our backup plan was pretty simple. If the socket connection to the HealthSuite device cloud was disrupted, we just started doing a polling for commands every 10 seconds, so that eventually we could turn on your lights. That way, we still provide the consumers with a degraded service at the cost of doing additional costly HTTP requests. The impact of this backup strategy is enormous. With only 10 users, we already start doing 1 request per second to our backend. And this might be fine. But if we would ever reach 100,000 users, we had to scale up with our AppEngine instances, or we would deliver ourselves a distributed denial of service attack. So we knew that this solution could scale at the cost of cost, but it would not scale for us money-wise if Philips Hue would achieve its initial success. We accepted this risk at that point in time and proceeded with the release to the market of Philips Hue in 2012. That was a blast from the past. Now today we can all look back and say that Philips Hue has indeed been the success that we expected it to be. It has integrations with Amazon Alexa, with Google Home, with the Nest thermostat, and many others. And it is installed in millions of homes throughout the world. But so is this product, the wall switch. This is our competitor. In the early days of Philips Hue, we did not care about latency for our cloud offering. The original use case was out-of-home connectivity and integrations like IFTTT. But both of these expected you not to be present to observe the visual feedback and thus perceive the latency. But this has changed during the past 7 years. As Sam also showed in his talk, the cell phone coverage has become prevalent in all the populated areas. More and more people nowadays start to rely on their mobile internet connection instead of Wi-Fi, even while at home or at a conference. So we needed to adapt our architecture for speedy responses. And we knew where we could attain our biggest speed increase. If we could create the persistent connection as a WebSocket connection to the home system ourselves, instead of having to rely on the HealthSuite device cloud, this could save us many, many seconds of latency. But neither the original hardware nor our cloud application were capable of doing so. So we have evolved our cloud infrastructure with this single goal in mind. In 2014, we moved from AppEngine to AppEngine Flex, and we started using Node.js to prepare for having a data streaming solution. In 2015, Philips introduced the second iteration of their hardware, which was more powerful, and it was able to maintain a persistent WebSocket connection. And finally, to unlock the WebSocket capability, which Google AppEngine Flex unfortunately lacks, we finally moved to Google Kubernetes engine in 2016. And as an added bonus, this provided us with a way to better utilize our cloud resources. And this is how the core of our infrastructure looks today. It's a bit bigger now. We have broken apart our original infrastructure into smaller microservices. All users of the Cloud API go through one entry point. There is no distinction being made between our partners or even our own mobile application. First, we need to validate those requests to see if they are allowed to manipulate and control your home system before being submitted to our Redis queue-based. Our backend notifiers will then determine if and how your home is connected to our cloud, being it low latency via the WebSocket connection, or still slumbering and still requiring HTTP polling. Because for the original V1 bridges, we still have to rely on the Health Suite Device Cloud to wake them up and start polling for commands. Even after 7 years, those are still being catered for. And to give you some feeling of the scale at which we operate today, I present you with some numbers. We currently host everything from within one Kubernetes cluster in Europe. And inside this cluster, you will find 25 individual microservices, of which we have spawned 600 instances on about 160 machines on any given day. This infrastructure is being developed and maintained by merely 10 developers. As such, it is imperative for us to utilize powerful tooling to keep our operational efforts at the minimum, or otherwise our development would come to a grinding halt. This was also a reason why we were very happy with Kubernetes hosted by Google. We could minimize our operational burden by this, while our scale is this big. Going from where we started and where we are today, we have faced many bumps in the road. Some have been big, some have been small, and some have been noteworthy and some not so. So let me show you some of the things that we have learned along the way. First thing, logging. As a developer, we are all used to logging information from our applications. This makes sense. It is the first way of knowing how your application is behaving. And it is one of the most basic ways to debug your code. But as the size of your user base is growing, even small amount of logs will start to add up. As Valentin also mentioned yesterday, you will end up with so much data that it will start to hurt you. Instead of providing you with insights, it will only clutter your vision. I can recall an incident in our journey in which one of our services was generating so much logging information that merely shipping the logs from our application to the Google Cloud logging infrastructure degraded the performance of our application, causing more logs to be generated. Since then, we have pruned our log levels back to only log warnings and errors, but this still adds up to about 10 gigabytes of logs a day. The second issue that we have faced with logs is that once we started introducing microservices, our logs became distributed also all over the place. And it will become very difficult to piece back together what happened during the lifecycle of a single request. To solve these issues, we have implemented structured logging using JSON, of which as much as possible contains a marker like a request ID, so we can trace our logs over our infrastructure. Being able to filter these logs inside Stackdriver using the logging UI is tremendously helpful to gain more insight in what is going on ad hoc. But the final piece of the puzzle is, of course, to have your logs stream from your application through Stackdriver into BigQuery, where you're able to dive deep into your data using its powerful querying language. With us pruning our logs so vigorously, we were now able to discern errors and were possible to correlate those to the microservices daisy-chained in a single request. But we now had lost the other benefit of logs, which is knowing if your application is behaving as expected. To get this back, we needed to introduce metrics, anonymous counters, which are reporting back from key features in your codebase, how things are going. Are requests being handled slowly? Are accounts being created successfully? If so, how often? But merely having metrics is not the solution, because you will end up with all graphs containing anonymous signals, which tell you that things have happened, but not what made it happen in the first place. What you want is to be able to see the bigger picture, to be able to combine all the signals and see the grid, see the ripples from the cause all the way through your system when a problem arises. We have invested heavily in using Datadog instead of Stackdriver to help us see this bigger picture. By combining time-based events like the deployments, time shifting our metrics to see their historical trend, and merging this all together into dashboards, we are now able to see the impact of our deployments or even an outage of an internet service provider it has on our system. We are able to pinpoint issues in our system back to the individual microservice from which they were caused. And then we can decide to zoom in on these signals and enable logging for certain parts of the code base to debug further. When we moved towards Kubernetes, we felt the natural gravitation of breaking apart our monolithic application into smaller microservices. And this has given us many advantages. We could start deduplicating our code base, simplifying coroutines, and it even allowed us to experiment with new languages like Go, without having to abandon a lot of application code that we invested in. But as the amount of microservices grew, my team became overloaded by the amount of yak shaving that needed to be done to simply maintain our microservices. An example of this is that we decided to uphold global standards over all our microservices which utilized the same technology stack. This so we could reduce the complexity when we're having to develop for multiple components. But then we ended up with, for instance, a mega yak shaving ticket like this one. Simply moving from Yarn to NPM became a struggle. And what we needed was more automation to help us with the simple but costly stuff, which we could do without. So then we decided upon continuous delivery, because when we were still a small team with a handful of applications, it did not make sense for us to start heavily investing in continuous delivery. But now with so many applications on which we all made improvements, we needed to get these out onto production as fast as possible. And we had struggled for a long time which solution we should be using. We had built up extensive command line tooling to automate already as much as possible from our way of working. And we saw that a lot of the features that we relied on were absent in tools like Spinnaker or Jenkins X or even CircleCI. So in the end, we sought for a solution in which we could leverage our existing scripting, and we decided that if we could at least automate our trivial deployments, that we already had a significant amount of benefits. And then we started using GitLab pipelines so that we could automate our scripting, so that it can run our tests, can compile our application, and can deploy it to our different environments. And as you can see in this screenshot, a small change to our code base can now be deployed in as little as 30 minutes towards production. And while we were still 2 engineers, everything felt very easy. We knew all the moving parts of our application. But that has changed. We gradually grew the size of our development team in the last year. We gradually grew the size of our development team. But in the last year alone, it has doubled from 5 to 10 developers. And as the team grew and our application landscape started to mature more and more, we started to struggle. Not everyone in our team knew all the historical choices that we had made. New decisions were being made all the time, and even discussions were being rehashed multiple times in different combinations of team members to reach conclusions. Newer members in the team found it very difficult to pick up work from components they were less experienced with. They had the case of the imposter syndrome, the feeling of not being able to add value to those components. And to add further strain to our knowledge availability, we started to become a distributed team in which team members wanted to work from home or the office nearest to their home. So we faced a very difficult problem: how to properly share knowledge within your team. And we approached it as a problem that we can never fully solve, but we are making small steps in the right direction and are iterating upon those. Since then, we have started using architectural decision records in a centralized repository. This helps us to prevent the rehashing of discussions which we had in the past, or at least not forgetting the reasoning why we have made decisions and took a certain course of action. And these records are not much more than a markdown template in which we describe when we made a decision, given the context of that time, and the known consequences that we accepted. Since these records are also stored in our version control, they can be amended if we have new information coming available in the future. And once my team embraced this additional step of documenting even our trivial discussions, our benefits were enormous. And it feels kind of obvious, but when my team was still small, we did not use pull requests extensively. Most features were either pair programmed or they were informally discussed and then being built. But since then, my team has revoked my rights to push on the master. Nowadays, we have mandatory pull requests for every change unless it has been pair programmed. This is because our most important reason is that we were utilizing the pull requests for knowledge sharing. And we wanted to solve the imposter syndrome that my team members experience by having others either review your changes and give constructive feedback so that you learn faster, or having rookies ask questions so that they can learn from the answers. But what is very important is that we do not use pull requests to focus on things that we never want to overlook and that we can automate easily. To do so, we have used Danger to write our own checks, which are applied to our pull requests, and it reports them back if it finds anything. And these kinds of checks help us to not forget very important things, like adding tests to changed code, and it even prevents us from shipping dependencies which contain known security vulnerabilities. The changes that we have implemented in our development process have all helped us to get new members up to speed faster, have knowledge be available even when you're not in the office, and most importantly, has made my new team members feel welcome and able to reach a certain baseline of knowledge to be empowered to help them in their journey. These examples are but a few. I could talk all day about the failures and successes that we have experienced in the past 7 years while developing and maintaining the Philips Hue cloud. But let us do a short recap of the learnings that we attained from these examples. When we started using AppEngine, it was primarily because my team had no designated system administrators. DevOps was not a term at that moment in time. We knew this, and we needed a solution in which we could develop our application carefree. And because once we arrived on Kubernetes, we had to invest heavily in our DevOps tooling and knowledge. There are so many new layers in which things can go wrong. Now you have your app, it's being ran in a container, on a node in a cluster. And we have also been in contact with the Google Site Reliability team to adapt their way of working as much as possible. For us, this was a logical progression due to the size and requirements of our application. But if you are able to stick with a fully managed serverless application framework like AppEngine or Cloud Functions, that would most certainly be my course of action. And we also tend to skip metrics when we are developing our applications. But it is very important to see the difference between metrics and logging statements. Metrics, they help you to see the bigger picture, what is going on right now. They are anonymous, inexpensive to store, and easy to slice and dice into easily digestible dashboards. And they really start to shine once your metrics rate increases. Logs, they help you to diagnose logs help you to diagnose after the error has occurred. Why did it go wrong? Logs and storing and processing them can become costly very fast. Once the rate at which you produce logs becomes big enough, you will not even be able to discern anomalies in your code. Both metrics and logs have important roles to play in your application, and you should both use them to your advantage. And although the move to Kubernetes led us to start breaking apart our application into smaller microservices, which were easier to maintain, reason about, and add features to, it is not all glitter and glamour. You have to make sure that your deployed versions of microservices are compatible. Yak shaving can spread pretty fastly, and you also have the danger of ending up with a distributed monolith instead. But in the end, the biggest deciding factor in this is your team. If it is experienced enough to circumvent these downsides, then a microservice architecture might be the best way forward. This also brushes upon my last learning. Of all the challenges that I have faced, the most difficult one was scaling my team. There is no quick solution which you can apply to every situation so that your team will work smoothly. You will have to take the learnings from others like Spotify and adapt those to your current needs. And then you can iterate on those to get to a better place. There are still things on the horizon that we are looking into to assess if they add value for the consumers of Philips Hue or improve the quality of our cloud infrastructure. A very concrete example of this is multi-region hosting. We are currently still hosting the Philips Hue cloud only in Europe. This originally was because we started out in Europe, but it is nowadays more due to the privacy concerns that we have with the handling of sensitive data of European citizens and shipping those either to, for instance, China or the United States. And of course, the problem of having only one region is that a consumer in the United States needs to pass the ocean at least twice. Once for sending its command to our cloud and once from our cloud to their home, adding unnecessary latency to their commands. We are also looking out into rollout scenarios of using Istio. We've heard a lot about it in the last 2 days. This service mesh solution brings a lot of functionality for us, which we have already built ourselves in the past, like service discovery, load balancing, circuit breakers, etc. Adopting Istio would mean that we no longer have to maintain these complicated parts of our code base and can rely on a well-established solution. To end my talk, I would like to give you one final piece of advice, and I can paraphrase. If everything seems to be under control, you're just not going fast enough. And to put this into perspective, never forget that the Google Cloud has offerings for every part of your journey, from a small, minimal viable product all the way to a big multi-million user cloud-hosted solution. I would like to thank you all for listening. I think we still have plenty time for questions, so I hope there are some.
Please raise your hand if you have a question. Okay, I see one.
Hey, it was a great talk. Thank you.
Thank you.
You said you're using GitLab CI,
Yeah.
but a lot of screenshots from GitHub. How does it work? You're mirroring all your repositories from GitHub to GitLab?
Yeah, so this is indeed something like a transitional period. We started with GitHub because we at first didn't. So GitLab has had some issues in the past with having outages and losing data of people. So we didn't trust GitLab with our code at that time. Still not. And we do value their pipeline proposition very much. So our GitHub code is being mirrored to GitLab, and then the pipeline is being triggered by that.
Bitbucket pipelines are pretty good as well, but they have availability issues. They could be unavailable for a couple hours once a month. Thank you.
Okay.
Hi there.
Hi.
Yes, I'm Toby. Your plane passenger.
Yep.
On the way here. So did you start monolithic and then move to microservices? Sorry if I missed that part.
No, you're correct. Correct.
That's correct?
Yeah.
I'm curious, is there anything you found out you didn't know when you moved from monolithic to microservices?
Well, when we started breaking apart the application, we didn't expect, so the issue that I mentioned, like that you're no longer able to follow your code, the log statements in your code. There was a complex mind boggler that we didn't foresee actually at that moment in time. And no, I think that's like one of the biggest issues that we faced, that we didn't perceive how big of an issue it would be.
It's a good answer. That's actually exactly the first thing that happened to me too.
Yeah. All right.
Well, thank you. More questions?
Hi.
Hi.
First of all, thank you for a really great talk. If it's not a big trouble, can you please go to one of the slides in the beginning where you had your current state of architecture?
The current state.
Yeah. Oh, there, this one.
Yeah.
So as I see here, every service is marked with Kubernetes label,
Yes.
but Redis is marked as Compute Engine label. Can you maybe talk a bit about this? What was the reason behind this? Thank you.
So our queue is based off Redis. Redis is non-persistent. This is with the reason that persistence with Redis is costly. And we have not moved our Redis instance inside of Kubernetes because it is now a pet. So we have to maintain it very carefully. And we know this is also a fallacy in our infrastructure. But we do not want it to be monitored and managed by Kubernetes, because then it could move our Redis database at the scheduler's will, and then we have an outage. So that is the reason why it is still being using compute. We do use some Redis instances with our microservices bundled, for instance, just for caching or faster responses. But because this is the queue which like glues all instances together, it is still a Redis database. We have thought about using PubSub instead, but re-architecturing this part of the application for now didn't seem like a sane business proposition.
I have a question about hardware, about this controller that I have. So use case, for example, I do not have Wi-Fi. I have Wi-Fi, but I do not have internet connection. But app from my mobile still can control these bulbs. So I have a question: what inside this controller, and how do you sync it with cloud when internet connection back?
Yeah, so the Philips Hue light bulbs, they degrade pretty decently. So when you have internet connectivity, your for instance your mobile application will try to reach out via the internet to see if your local system is available, and if so, might use the internet connection. But even if you're at home, it will just start using the local connection. If you don't have Wi-Fi, if you don't have internet but still have Wi-Fi, then your mobile device is still able to reach your home system, so it will still use and interact with your system. And finally, if you don't have Wi-Fi, yeah, you can still use my competitor, the wall switch, to turn on your lights.
Question is, what the hardware and software in this home controller? Is there some, I don't know, Docker container that use same API that used, or what?
So the API which is being ran in your home is actually transparent to what we are hosting in the cloud. So that's also the reason why the app is able to connect with both, actually.
Are you using MQTT protocol?
No, we are not using MQTT, unfortunately. We are doing experiments with the new software to start using MQTT inside of the device.
So this control connected to the cloud using a WebSocket or just socket, and but you're not using MQTT, only just sockets.
Check. Did that answer your question?
Yeah, I'm thinking I have similar problem.
Otherwise, you can come to me afterwards and we can discuss it a bit more further.
Hello.
Hello.
I have less technical question. Is end-to-end testing on your side?
Once more.
Did you organize end-to-end testing if it's on your side?
So, if I understand your question, you want to know more about the testing of how we are doing the testing of this product, right?
Yeah, the whole end-to-end process.
Yeah, so we have multiple responsibilities. My company has an obligation towards Philips that this cloud infrastructure does what it needs to do, that it does what it needs to do. So we have extensive test suite that we, in isolation, can verify that the cloud infrastructure, given the correct input, generates the correct output. This is our obligation. Once we deliver our new firmware, our new software updates, we have a full integration suite with physical hardware at Philips, which does an end-to-end test to verify that the cloud connectivity still also works with hardware, because it is a combination between hardware and cloud. And then finally, we do a rollout to the beta users in production to observe if we have missed anything before we do a global rollout. Right. All right.
Anyone else? One more question.
So I heard you want to do multi-region. What's your biggest challenge to doing multi-region?
So our biggest challenge with multi-region is we've been actually waiting for Kubernetes to mature with regards to multi-region support, and that's been progressing pretty steadily. The biggest challenge that we have with multi-region is we have these WebSocket connections to your home, but we know we don't have like a socket connection from the entry point to your home directly. So it might be that you are in a cluster in Europe, but your stable connection to our cloud is actually in US. And we need to solve that part of the equation, that we do cross-cluster connectivity so that we can link those two together. All right? Are there more questions?
Anyone else? We still have some time.
All right. Good. I would like to thank. Oh, there's one more.
My question is, why have you decided to work with Philips as another company the same?
So this is actually a very fun question. So in 2011, Philips was still one very, very big company. Philips Medical, Philips Lighting was the same company, and they were very enterprisey. So they had a lot of regulations and were very strict about procedures because they were also developing medical equipment. So they couldn't face any legal issues with regard to anything that they do. But this was really hampering their possibility to evolve and to make new products. So they had an inventor of this actual product, and the board of directors gave him like the undercover mission to find a partner to develop this outside of Philips, and he came to us.
Thank you. And am I right? If you want to work with another company, you can do it, or not?
Me?
Yeah.
Yeah. So I work at Q42. We are a project agency, and we work for Philips, but I'm not purely working for Philips.
Okay. Thank you.
All right.
I think that's it. Cool. Thank you, Mark, for great presentation.
Thank you all.